In this video, we're going to talk about the domain and range of an exponential. So, quick review. We previously discussed domain and range for a lot of different, well, not a lot of different functions, a couple of different functions. Domain is the set of inputs. That's typically our x values that we can plug in. And range is the outputs. It's the y values that we get out. So domain is x, range is y. It's an important definition just so you know which one's which. All right, let's graph f of x equals 2 raised to the x and the determinants domain and range. All right, so we know there's a horizontal asymptote at 0. 2 to the x kind of starts off really low, almost like a flat line. Almost like a flat line, not quite a flat line, even though that's how I'm drawing it. And then after that, it turns and shoots up. All right, so domain of this function is all the x values. So I'm definitely hitting all of these negative x values over here. All right, so this keeps going left forever. And you might think that like this goes up and I don't hit these ones, but the graph is always slowly going to the right. Like I could plug in 10, 2 to the 10th is a number. It's just really, really big. 2 to the 11th is a number. So the domain is all real numbers. Not super easy to tell from the graph. I think the left-hand side's easy. You're hitting all the negative values, but this looks like it almost becomes vertical, but it's still very slightly slanted to the right. All right, so it's going to take a long time to get to these x values, but eventually you do. All right, if you want to make this as simple as possible, you say domain equals this fancy R with 2 lines represents all real numbers. All right, so real quick, that's a domain. A range is the y values I hit. So you can see down here, this part of my graph is completely empty. I don't hit any of these y values. All right, so my range hit all of these positive numbers. You can see really quickly I'm hitting all the positive numbers really quickly as I'm going up. So my pain range is everything that's bigger than 0. I'm not going to get any negatives. And then the question is, should I put this equal sign here or not? If I put the equal sign there, it means at some point I get 0. But do I ever get 0? If you zoom in here, I actually even did a good job here of leaving a little gap. There's always a little tiny gap between the left-hand side of your exponential and actually 0. These values are getting really small, but they never actually hit 0. So we actually don't want this equal sign here. Right? Our y values are strictly bigger than 0. All right, so if you put this equal sign here, it won't be 100% correct. I'm going to make you fix it. All right, so remember, domain is all real numbers, and y is only the positive values and not 0. All right, so quick summary. Every exponential function I'm going to give you, the domain is all real numbers. So real nice if you get the skill check or something. You don't even have to think about that. For the range of the exponential functions, it's always going to be dependent on the horizontal asymptote. So our original exponential is 0. Let's look at some other examples. I find the domain and range of this. Well, domain, I'm not even going to think about it. It's all real numbers. If I start doing really weird things, I can make this not true, but we're not going to be doing that in this class. So the domain of exponentials, all real numbers. What's the range going to be? I got to think about where the horizontal asymptote is going to be. I have this minus 4, so my horizontal asymptote is going to move down 4. 1, 2, 3, 4 to there. I think it should be a dotted line, quicker for me to make a solid line. All right, 3 to the x looks something like this. 3 to the x minus 2, just move it to the right 2. And then negative flips it upside down. So my graphs don't have to be perfect, but I'm doing range as a general sketch, but now I can see my range is the y values that are strictly less than, because this negative is making me go down here, than that horizontal asymptote at negative 4. So just drawing a real quick sketch, and sometimes drawing quick sketches for students is a little scary because you want it to be super accurate. So if you want to take the time and do it just like we were when we were graphing these by hand, you can do it that way. But for me, I just kind of see where the horizontal asymptote is, see which direction my graph is growing, and that can get me my range. I 1/2 to the x plus 1 plus 2. I know that plus 2 at the end is going to cause my horizontal asymptote to go up 2 to there. I 1/2 to the x. It looks like, oops, looks like this. Whoa, that was terrible. Looks like that. And then plus 1 just moves it to the left 1, so it still looks like that. So my domain is all real numbers, and my range is the y values that are above this horizontal asymptote, so y is strictly bigger than 2. I put these curly brackets around here because it's more precise. I'm not really judging you guys on your mathematical notation too much, but that's the way it should be written. All right, so here's one for you to try on your own. All right, find the domain and range of this function. All right, I'll show you the answer in 3, 2, 1. All right, so that's our domain and range. Y, domain, it's all real numbers because they all are. Range, this graph is going to move down 5 to there. And then because of this negative sign here, my graph is going to go upside down like that. All right, so that's why it's less than -5. All right, so domain for every exponential I'm going to ask you is all real numbers. Again, I can make ones that aren't, but that's not really necessary. And then range is always dependent on the horizontal asymptote, but remember, it cannot equal that. So if you were to do something like this, you're not going to pass your skill check because that equal sign is really important. That's not there. And then graphing the function, for me, I can very rarely just look at a function and tell the range. So graphing it and kind of seeing what y values I hit is always going to be a helpful strategy.